Alrighty, guys and gals, back again with another fun-filled, action-packed, flipped Geometry Classroom video. And today we're going to be learning about different segment lengths, intersecting chords, secants, and tangents on that circle. And we're going to be learning about those rules about them. So without further ado, let's jump right into it, into the tangents. Alrighty, here we go. So let's look at the rule. If AB is tangent to circle C, then AB is perpendicular to CD. All right, so take a look at perpendicular means 90 degrees, remember? Take a look at our diagram right here. You can see that AB is a tangent. All right, it's tangent. It's intersecting at one point. And then you see CD. Well, AB, that tangent, is perpendicular to CD, which means there's a 90-degree angle right there. So that is one of the rules. So we're going to use this in some problems. So let's take a look. For example, in the first we do, let me enlarge this. Okay. All right, take a look at this. We have a tangent, because look, it's intersecting at one point. Bam, intersecting at one point. And then look, we got this radius drawn to the point of tangent C, which means this has to be right angle because it's perpendicular. That's the rule about the tangent. And then the radius going down to the point of tangent C. So if this is a right angle, how can I find X? Because look, whoa, wait a second. They give me a big hint here. It looks like a right triangle. There's a certain theorem we use when we're trying to find a missing side on right triangles after they've given us two sides. I think it starts with a P and it rhymes with Pythagorean theorem. That's right. So the Pythagorean theorem, we can use that all the time, and it's going to be a squared plus b squared equals c squared. Where's my hypotenuse here? It's going to be x because that's the side across from the 90-degree angle. So I don't know what that is, so I'm just going to leave that as x squared. Okay, equals a and b is just the two other sides, so I'll put 9 as a, so 9 squared, plus b, let's just put 14, so 14 squared. All right, so then we're just going to solve this out. 9 squared is 81. 14 squared is 196. 196 equals x squared. 81 plus 196 is 277. 277 equals x squared. I don't want x squared. I want x. So I need to take the square root on both sides. That gives me x on the right side, which is what I wanted. And on the left side, when I take the square root of 277, it gives me 16.64. So the measure of x is 16.64. All right. Now you guys try the one on the right side. Next up, we got two tangents from the same external point. What does that even mean? Let's read the definition. We'll find out. If AB and BC are tangent to circle D, then AB equals BC. Notice AB and BC, AB and BC, they both come from point B right here. And they're both tangent to the circle. Look, AB, bam, tangent. But it's coming from point B. BC, tangent. But it's coming from point B. Well, in that situation, where it looks like a gnome head or something, then AB and BC are the exact same. They equal each other. The measures equal each other. So they are congruent. Bam, like that. Or at least they equal each other. So let's take a look at an example. How would we use this? Look at the we do. This first one right here. Bam. Now let's take a look at the picture. We got XY. So it's coming from point Y. We got WY. Also coming from point Y. Both of these are tangents. They make a little gnome head thing, which means that they equal each other, right? So what equation can I use to solve for x? I can take the 43 minus 2x right there. 43 minus 2x equals 12x plus 1. And then we're just going to use algebra to solve for this. So let's go ahead and add 2x to both sides. That leaves me with 43 equals 14x plus 1. Subtract 1 from both sides. That leaves me with 42 equals 14x. Let me move it over here. 42 equals 14x. Then I'm going to divide both sides by 14. And 3 equals x. And I have solved for x. You guys try the one on the right side. All right, next up, we've got intersecting chords or secants on the interior of the circle. So pretty much, look, we've got two. Look at this. We got two little intersections. We got an intersection on the inside of our circle, right? And the rule here, guys, is you see how there's two lines? I've color coordinated them, right? But each of these two lines is broken up into segments. See, we have segment A on this line, and then segment B on that line. And on the other line, we have segment D and segment C, right? Well, the rule here is A times B equals C times D. So you just take the two parts of the line, multiply them together, and they equal the multiplication, the product of the other line. So in a quick example, that was kind of hard to say, but in the quick example, let's take a look at the we do. So first we need to recognize the two lines, right? So one of our lines right here, bam, and the other line is right here. So I need to look at the two parts of my line. One of my line, the blue line, see that I've highlighted in blue? The two parts that make it up are 15 and 8. So I'm going to multiply those together, 15 times 8. All right? And that is going to equal, what are the two parts on the other side, other line? One of them is 3x minus 5, so 3x minus 5 times, what's the other segment? 12. All right, so now I just need to use algebra and solve this out. 15 times 8. What is 15 times 8? That's 120. Equals, now I need to distribute right here. So 12 times 3x is 36x. And then 12 times negative 5 is negative 60. And then I need to use algebra to solve for x. So I'm going to add 60 to both sides. 180 equals 36x. Then I'm going to divide both sides by 36 to get x alone. And that leaves me with 5 equals x. And I've successfully solved for x using the rules. Now you try the one on the right side. Righty, here we go. Second to last. Intersecting secants on the exterior. So we have, check it out, from the same point on the outside. We got bam, one secant right here. Okay, cannot trace. One secant right here. And then another secant right here. And now the rule from here is we're going to take A, so one of the segments right here, one of the lines, multiply that by A plus B, and then we're going to take that equals C, the segment right here, times C plus D. So when we look at an example, it will make more sense. So let's take a look at the we do. All right, we're solving for x here, so we're going to write an equation, right? So let's recognize the two lines and the two parts that make up the lines. So on one of my lines, look at this. I'm going to color coordinate this just a lot. So one line's right here, right? But the outside portion of this line is right here. It's at 8. Okay, my other line is right here, and the outside portion of this line is right here, the 7. So now my rules say I'm going to take the outside portion, so 8 times the outside plus the inside on that line, so 8 plus 3x plus 4. Okay? And then that's going to equal the outside portion of the other line, 7. Okay, that's not the right color. 7 times that 7 plus the inside portion of the other line, which is 5x plus 2. All right? And then we just use algebra here to solve it. So we need to simplify all our terms first. So inside here we have 8 plus 4, so we're going to have 8 times inside the parentheses. 12 plus 3x. And then my other side, we've got a 7 plus a 2 inside, so we're going to simplify that to 9 plus 5x. All All right, now we're going to have to distribute. So we got 8 times 12. What is 8 times 12? That is going to be 96. Then we've got 8 times a positive 3x. 8 times 3x is plus 24x equals, what do we have on this other side? 7 times 9. That's 63. And then we have 7 times 5x. That is plus 35x. All right, now I'm going to subtract 24x from both sides. That cancels that over here. That leaves me with 96 equals 63 plus 11x. All right, next I need to subtract 63 from both sides. Bam, that's gone. And that leaves me, I'm going to bring it over here, with 33 equals 11x. My last step here, divide both sides by 11. And that means that 3 equals x. And we've solved for x. So now use this rule to try the problem on the right side. And finally, we have an intersecting tangent and a secant. You see right here, A, that is a tangent because it's only intersecting at one point on the circle. But then this other one over here, this other line, the secant right here, because it's intersecting at 2 points. All right? And now the rule right here is we're going to take that tangent, A, we're going to square it, and that's going to equal the outside portion, B, times B plus C. So maybe it'll help if I change the colors, but like this. B plus C. All right. So let's take a look at a we do example to see how this works in action. Once again, we're solving for x. So let's take a look and recognize what we have here. My tangent is right here, LM, because that's only intersecting at 1 point. All right, and then on my other line, I've got this whole thing. That's a secant because it's intersecting at 2 points. But the outside portion of the secant is this 8 right here. And so the rule is we're going to take the tangent, which is 16. We're going to square that. And that equals the outside portion of my secant, which is 8, times, then we just add those two segments together. So 8 plus 5x minus 1. All right, so now let's just use algebra and solve for x. So 16 times 16, because that's 16 squared, 256 equals, let's simplify what's inside. 8 minus 1 is 7, so we got 8 times 7 plus 5x. All right, and now we need to distribute. So we got 8 times 7, that's 56. And then we have 8 times 5x, that's plus 40x. And then on my left side, I have 256. So I'm going to subtract 56 from both sides. So that gets rid of that one. And that leaves me with 200 equals 40x. Now I want to get x alone, so I'm going to divide both sides by 40. Goodbye, 40. And that leaves me with 5 equals x. All right, so now you guys try the very final you do problem on your own with that rule, and that's going to bring these notes to an end. See you in the next one. Peace!